Hello geometry peeps. Today we're going to talk about classifying triangles. And first we're going to start by classifying triangles by angles. Now there's four types of triangles when we're referring to the angles. The first one is an acute triangle, and in an acute triangle all of our angles are exactly that, acute, which means each of the angles measures are smaller than 90 degrees, however greater than 0. So they exist, but they're smaller than 90. So an example would be like if this angle's 50, this one's 55, and this one's 75. So again, they all sum up to 180, but they're all less than 90. Okay, an obtuse angle is when one angle is greater than 90. So one angle is less than 180, however greater than 90 degrees. So let's say this angle was 135 degrees. That would be my obtuse angle, which makes this an obtuse triangle. And then these two would still be acute. So you just need one obtuse. A right triangle, you need one right angle. So one angle is right. So one angle measures 90 degrees, and the other two can be whatever, as long as it adds to 180. And in an equal angular, all the angles are congruent. Okay. So all the angles are congruent. Now, in order for them to all equal 180 and be congruent, all the angles have to be 60 degrees. So in an equal angular triangle, they are all 60 degrees. Alright, so that's classifying by angles. So if I give you a picture of a triangle and say classified by angles, you're going to assign it one of those three names. Alright, and then we got classifying by sides. Now classifying by sides, there's only three types. The first is scalene, and in a scalene triangle, all the sides are ... different lengths. Okay, so no one side has the same length. So an example of that would be like this is 6, 12, and 13. All three are different lengths. Okay, in an isosceles triangle, at least two sides are congruent. At least two sides are congruent. Alright, so like these two sides could be the same. 13 units, 13 units, 6 units. Now, an isosceles triangle, we'll go more into it later, but it has some very important pieces. The top angle here is called our vertex angle, and then the two bottom angles are called my base angles. So those two would be my base angles, and then the two sides are the legs of my triangle. Alright, and then we have equilateral triangle. In an equilateral triangle, all sides are equal. All sides are equal, so they could all be 8. Now what's awesome about an equilateral is when all the sides are equal, the angles are also equal. Alright, because it has to be 60. Cool? Okay, now what in the world are we going to do with this? So here's some examples. The first one, it says, equilateral triangle PQR has sides measuring 4x plus 2 and x squared minus 10. Find the numerical measure of side PR. So we know we have an equilateral triangle, so we can kind of draw it. And we know it's PQR. Doesn't matter where the vertices go, because all the sides are the same. One of the sides is 4x plus 2. And one of the sides is x squared minus 10. Now, because it's equilateral, we know it's all the same. So I can set my sides equal to one another, because all the sides are the same. Now, I have an x squared, so whenever I have an x squared, I got to get my equation equal to 0. So I'm going to subtract 4x. X squared minus 4x minus 10 equals 2. And I'm going to subtract 2. So x squared minus 4x minus 12. So I need two numbers that multiply negative 12 and add to negative 4. So that gives me negative 6 and positive 2. And when I apply my zero product property, my two answers are x equals 6 and x equals negative 2. Now we need to test that they both work. So let's go with 6. We want to find the measure of PR. So PR is 4x plus 2. So instead of x, I'm going to substitute in 6. 4 times 6 plus 2 is 24 plus 2 is 26. So 6 checks out. Now let's try negative 2. 4 times x, which is negative 2 plus 2, is negative 8 plus 2 is negative 6. We cannot have a side that's negative 6 units in length. You can't have a negative length. So negative 2 is not a solution. 6 is our only solution. And to answer the question, PR is 26 units. Alright, that's first one down, 2 to go. Now number 2, use the given information, draw each triangle, classify in terms of sides and angles. So it wants us to classify sides and angles. So we have triangle KLM, and we know angle K is a 90. So we know we have a right triangle because we have a 90-degree angle. And we have to make angle K 90. That's very important here. So we have to call that angle K. L and M can go wherever. And then it says KL is 2.5. So KL is 2.5 centimeters. KM is 3 centimeters. So we know we have a right triangle because we know we have a 90-degree angle. So now we've classified it by angles. Now to classify it by sides, we know these two sides are different and the hypotenuse is always the longest side. So if the hypotenuse is the longest side and these two are different, that means all 3 sides are going to be different, which makes it a scalene triangle. So we could say this is a right scalene triangle. Alright, pretty easy. Let's look at this one. Triangle DEF, and angle D is 150 degrees. So 150 is an obtuse angle, so we got to draw an obtuse triangle. So I'm going to try to make that bottom angle there a little bigger than 90. Alright, so it's bigger than 90, and we know that has to be angle D. And it's DEF. And it says DE equals DF, which equals 1. So that means if DF is 1 inch, DE is also 1 inch. So we know these two are congruent. So we know we have an obtuse angle, so it's an obtuse triangle. And we know 2 sides are congruent, so that would be an obtuse isosceles triangle. An obtuse isosceles triangle. Alright, that's it for number 2. Number 3. The perimeter of a triangle is 28 inches. If 3 sides of the triangle are x squared plus 3, negative x plus 12, and 2x plus 1, solve for x and classify the triangle by sides. So classify the triangle by sides. Alright, so now I'm just going to draw a quick sketch. We don't know what it looks like because we know nothing about it. We know one side is x squared plus 3, one side is negative x plus 12, and one side is 2x plus 1. And more importantly, we know the perimeter is 28. So remember, the perimeter is if you add up all the sides. So I know x squared plus 3 plus negative x plus 12 plus 2x plus 1 added all together equal 28. Alright, so let's combine my like terms. I have my x squared. Negative x plus 2 is plus 1x. 3 plus 12 is 15. Plus 1 is 16, equals 28. Now we have an x squared, so we got to get it equal to 0. So I'm going to subtract 28 to get x squared plus x minus 12 equals 0. So now we have our quadratic equation. So I need 2 numbers that multiply to negative 12 and add to positive 1. Well, that's positive 4 and negative 3. Zero product property tells me x is negative 4 and x is positive 3. Now we have to test my solutions. Let's just pick any side, 2x plus 1. So 2 times negative 4 plus 1 gives me negative 8 plus 1, which is negative 7. So I get a negative result on my side, so that side can't be negative 7, so let's test 3. 2 times 3 plus 1 is 6 plus 1 is 7. Alright, let's try it in another one. Because we have to determine it by the number of sides, so we know this side is 7. So the opposite of x, the opposite of 3 plus 12 gives me negative 3 plus 12 is 9, so this side is 9. Then I have x squared plus 3. So 3 squared plus 3 is 9 plus 3 is 12. So 7, 9, and 12. To classify this triangle by sides, we would say it is a scalene triangle because all 3 sides are different. Alright, that's all I got. See ya.